Good morning, my name is Vanesa Rodríguez, and now I will address more the water, environment, food nexus, or trade-off nexus, in a particular case in the very particular ecosystem in the Brazilian Atlantic forest biome within the Rio de Janeiro state. This is the classical outline, nothing new here, but I start directly introducing you this area. The Brazilian Atlantic forest has been under pressure for centuries. It is a biodiversity hotspot because it harbors a high diversity of endemic species. However, only 8% of the whole forest cover remains. This biome alone provides around 80% of the GDP of Brazil because it harbors the two main metropolises, Rio de Janeiro and Sao Paulo, for example. And therefore also they provide, this ecosystem provides food and a serious amount of vital ecosystem services. However, it is under pressure and there are already conflicting demands, especially regarding water issues and other ongoing development pressures. For example, the launching of the Conceptual, which is the biggest petrochemical complex in the history of Brazil, which is going to be located close to this area. So we come to this. However, of these pressures, forest ecosystems are vital to provide such ecosystem services. So how to motivate the farmers? How do we address this challenge? Motivate farmers that they improve ecosystem service provision, but at the same time consider demand for agricultural products, and how do we make it in a considering cost-efficient criteria? This is just to show you that we consider mainly two levels of analysis. At the farm level, considering farming systems being influenced by several factors, especially the technological or environment that shape their decisions, and they have the outcomes and decisions that affect directly or indirectly ecosystems, and the way back, the ecosystems providing services to farming systems. So we are addressing three main questions here. On the one hand, which environmental conditions affect provision of this watershed service? In our case, we concentrate on water quality for public supply, and which are the costs of this supply. We will be talking about opportunity cost. Second, what are the current treatment costs of land use related water quality indicators? We are going to deal with turbidity because this is relevant for the water utility, the state water utility company. And we'll be talking about what are the trade-offs between water supply, environment, and food for this particular context. So let me tell you, please, about this study area. This watershed, it's called Guapi-Macacu watershed within the Rio de Janeiro state. It's very close to the big metropolis of Rio de Janeiro. And we selected 3 sub-watersheds with high, where there is also a river network sampling monitoring along this watershed, and we have selected 3 different sub-watersheds which present a different mix of the most important land use systems, which are forest, agriculture, and pasture lands. This is an area about 1,200 square kilometers. Basically this. And about these 3 selected areas, we selected one, for example, which refers to the is our reference zone, which is an area with high forest cover, high proportion of forest cover, while the others have a different mix between pasture and agricultural lands. We consider also pasture lands and livestock production systems, where you can see typical systems, landscapes, where half oranges predominate in the landscapes, and wood pastures are being, they also happen in high relief areas. So how did we do this? To calculate the supply, the opportunity cost, we collected contextual information, we designed a service and did a sampling, the spatial identification survey household, and after organizing and making a consistency of this primary data, we selected farming systems, and then we carried out a cost-benefit analysis. And at the end, we came out with opportunity cost calculations for the main land use systems for agriculture and pasture, on one hand. On the other hand, we consider environmental criteria, so we consider the vulnerability of hydrological resources in this watershed, considering state and pressure indicators. State are some indicators, for example, geology, relief, etc., and pressure are more anthropogenic, so land use change, nitrogen and phosphor discharge. We also did some expert interviews to technical staff at the Drinking and Wastewater State Company, and we characterized these user systems, considering key water quality parameters, indeed the avoided cost method, or applied the avoided cost method. Here's the same, one of the most important results. We calculate the spatial opportunity costs for pasture and agricultural systems, and we find very high opportunity costs for agriculture and low for pasture. Giving you an idea, this is in US dollars, about, how much is this in for 100, it's around 40. For pastures, are less than 100 reales, that is 45 US dollars approximately per hectare. While for agriculture, it ranges from 450 to 2,000 US dollars per hectare. Then we were interested in how to prioritize areas, addressing also these trade-offs. So the results of vulnerability here. So here you find in darker the areas with higher vulnerability of hydrological resources, so considering environmental criteria, and the spatial opportunity cost, the economic criteria. So out of these two, we overlay in these maps, we obtain a prioritization of areas for potential watershed service improvement. I did not mention that here at this point you find the water utility intake point that supplies around 2.5 million urban water users. So here, the areas in darker red would be the areas with higher environmental vulnerability and lower cost. Through this expert's interview and data from 11 years, we calculated that it would cost the reduction of 1% of turbidity for the water utility would cost around 16,000 reales, which would be around 7,000 US dollars. I'm talking about annual costs. But however, I want to emphasize also the importance of food supply, because I've been talking about watershed services. What about agricultural production? Agricultural production in this area is not area-wise very significant. However, is highly important since it produces products that provide the state programs, food security programs, like a school meal program and the state food security program, coming from family-oriented agriculture. However, agricultural practices happen often they're not appropriate for the region, and they're highly intensive, also due to the fact that we found this area very close to the Rio de Janeiro metropolis, and especially such practices of soil preparation lead to high erosion processes, or the increase of erosion processes, and this produce again a higher load of sediments into water flows, which at the end could or might increase water treatment costs. So with this study, we identified at one side the supply inputs and the demand inputs. So what the farmers are supplying in terms of environmental and economic environmental and economic inputs, and on the other hand, what is the demand? What is the demander willingness to pay for these particular services? And this is the most important issue to assess the economic scope of incentive-based watershed management. And as I told you, we find very high opportunity costs for agriculture and low to pasture lands. At the demand side, we find that the reduction of turbidity in 1% for the local water company would be around $7,000 US. However, payments for forest recuperation are likely to be cost-effective in sub-watersheds with a high proportion of pasture land. And we think that it is more appropriate to target efforts and concentrate in sub-watersheds where costs are lower, where the environment risk is higher, and considering agricultural, the importance of agriculture in this region. So not, for example, not banning agricultural land use all over, but concentrating in targeting areas. For example, protecting especially areas with high vulnerability, especially with slope, with forest, and applying good agricultural practices in lowlands for agriculture, and that would be also, that would increase productivity of agriculture as well. So like this, the target is to scope watershed protection in an area of high vulnerability, considering these factors, and low opportunity costs, considering the economic side, and including the food security aspects. And that's all I have to say. Thank you very much.
So we are pretty good in time. I hope air quality doesn't keep you from asking critical, provocative questions. So you have to start.
I just one more small question, because I worked in Europe about 25 years ago. And did you look historically at what the coffee industry did in the 19th century to the point where they couldn't grow it anymore? And did the soils at all revive? And is this what is happening here in terms of agriculture?
I did not get your question, sorry, the coffee.
Right, yes. In the throughout the 19th century, coffee was grown throughout this area, and the soils were so depleted that in the end it was not possible to grow coffee anymore. And I was just wondering whether the soils have revived to an extent, and now that agriculture is being intensively carried out there, that again the soils are being depleted.
Thank you very much for the question. Yes, indeed. I mean, they did recover to a certain extent. What happened also is it's the change of labor costs increased. There was a collapse in coffee boom, and labor, and then there is a social movement, a social load for labor, and then it increased a lot of the labor costs. So all of these fields were abandoned and left to forest regeneration in this area. In addition, legislation in the late 70s said that until a certain height, you're not allowed to cut off these secondary approaches. So high labor costs plus forest enforcement due to leaving some areas to regeneration, and agriculture was very expensive. Then came other cycles, like, for example, banana production. And for example, in this area, banana production is still very low, low productivity in comparison to other states. However, in the lowlands, it's quite intensive, and soils are pretty are quite recovered in comparison from this time. Thank you.